Hello dear grade 11 students. Here is a package of videos. I'm going to divide them in parts, and in these videos we are going to solve like kind of training exercises about systems of quadratic functions and stuff. Here comes the first one, the first system we are going to solve. Here is the second one, and here is the third one. So I'm going to divide each exercise, or I'm going to make a video for each exercise alone. Okay, let's start with the first one and let's go ahead. How to solve the system that's x cubed minus 2x squared minus 5x plus 6 strictly greater than 0, strictly positive, and this rational one that's x squared minus x plus 6 over x squared plus 2x less than or equal to 2. So as you see here, I separated them by colors. I'm going to solve the first inequality alone to get its solution, and then to solve the other inequality and to get the solution of it. And finally, we are going to make the intersection, the solution that's the intersection between the first and the second, to get the solution of the whole system. Here we go with the first inequality. It is x cubed minus 2x squared minus 5x plus 6. By trying 1, by evaluating 1 in place of x, we notice that we are going to get 0. And here we go. 1 minus 2 minus 5 and plus 6, we are going to get definitely 0. That means that 1 is a root of this, so x minus 1 is a factor as well. So using the long division, and here we go, the long division, by dividing x cubed minus 2x squared minus 5x and plus 6 by x minus 1. Here we go with this long division. Here we need x squared. Now x squared times x is x cubed. X squared times minus 1 is minus x squared. And don't forget, we have to change the signs because we make subtraction. So these will cancel and this will become plus, and thus we are going to have 1x squared minus 2x squared, then it is minus x squared, and this minus 5x will be down here, and 6 will be right down here. Okay, now what's multiplied by x to give minus x squared? It's definitely minus x. So minus x times x is minus x squared again, and minus x times minus 1 is plus x. Again, we have to put a minus sign outside, and we have to change the signs. Definitely these are going to be cancelled, and this is our aim, and this becomes minus, and thus we are going to get minus 5x minus x is minus 6x, and this plus 6 will be right down here. And now we are going to multiply x by minus 6 to get minus 6x. So we have minus 6 up, and here we have minus 6x, and minus 6 into minus 1 is plus 6. Then definitely this will cancel itself, which they are the same, and the remainder is definitely 0. Surely the remainder is going to be 0 because x minus 1 is a factor of this. So the quadratic factor of x cubed minus 2x squared minus 5x plus 6 is x squared minus x and minus 6. So by this, we can write x cubed minus 2x squared minus 5x plus 6 as a product of x minus 1 and x squared minus x minus 6. The root for x minus 1 is 1, and using the calculator, the roots of this one are 3 and minus 2. Now, how to use the calculator and to maintain the roots? You know the way of using the calculator. Let's use it and remind you of how to use the calculator. So first of all, I'm going to delete these, and here goes the calculator. So we have to press mode, then 5, then we choose this quadratic form 3, then we take a here is the coefficient of x squared, it's 1, b is the coefficient of x, which is -1, and c is the constant that doesn't have x, it is -6, and we press equal. Then we are going to get 3 exactly as we have here, and -2. So this is how to use the calculator in order to get the roots. Now if the roots have I here, if the calculator gives I, 2i for example, 3i, whatever, that means that this root is not real, and that means that delta is 0. So to know whether delta is positive or negative, delta is negative, sorry. So to know whether delta is positive or negative, you can use the calculator also. If the calculator gives a root with I here, that means a complex number, for example, and not a real number, not a real root, then that means that delta is negative and the quadratic function or the quadratic equation has no roots. Okay, but if the roots appear to be like this, real numbers, usual real numbers, then we say that delta is positive, and we have to apply the idea of same opposite same for the table, for applying the signs and writing the signs according to the rule of same opposite same, because there are two real distinct roots, thus delta is positive. Let's go back to the presentation. And here we go with the first inequality again. So as you know, we factorized it into two factors. One of them is x minus 1 with root 1, and the other is x squared minus x minus 6 with the roots 3 and -2. That means whenever I get roots, real roots, that means that delta is positive, and whenever delta is positive, to spread the signs on the table, I need to use the idea of same opposite same. Well, according to this factor, since it's linear, you know that when you put it on the table, so you put the roots on the table from the least to the most in the increasing order, -2, then 1, then 3. We put the first factor, x minus 1, which is linear, and according to linear factors, we put a 0 on its root, and we put the opposite sign of x before that root, and the same sign of x after that root. According to this quadratic one, the roots are -2 and 3, so as you see, we put zeros on the roots, and we put same sign of a. So what we mean by same? We mean the same sign of a. A here is 1, which is positive. Same sign of a, which means plus. Opposite between the roots, opposite sign of a between the roots. So here we have minus between -2 and the 3, and again we have to put the same sign of a outside from 3 to plus infinity. And thus, what is the sign of this whole polynomial? I named it 1, as you see here. We multiply minus times the plus, it is minus. We put the 0 again here because -2 is a root for all of this one, and not just for this one. Minus times minus is plus. 1 is also a root, so we put a 0 here. And plus times minus is minus, the 0 again, and plus times plus is plus. So we get minus plus minus plus. Now we have to search for the solution when it is greater than 0. Greater than 0 means when it is positive, and we don't have or equal, so all intervals are going to be open. Okay, so we don't have or equal, then all intervals are going to be open. We are searching for the positive part, for the numbers that make this one positive when we evaluate them. Then we search for this part and this part. So we are going to take the solution that's equal to the interval -2, 1 open both, and 3 plus infinity. So why is it opened at the numbers? Because we don't have or equal, but at infinity the interval is always open. So this is according to the first one, and now let's see how to solve the second one, and finally we are going to see how to get the intersection, the solution of the system, that's the intersection of solution 1 and solution 2. So solution 1, keep it in mind, it is -2, 1 opened interval union the interval 3 plus infinity. Now here we go with this second one. We have a numerator and we have a denominator, but before we have to take 2 to the other side, as you see here, to keep it 0 in the right side, because less than 0, greater than 0 mean positive or negative. So we care about putting 0 on the other side. So taking 2 to this side becomes minus 2, then making same denominator as you see. We put it over 1 and we multiply it by x squared plus 2x. So we are going to get minus 2x squared and minus 4x. Now the numerator becomes minus x squared, minus x and minus 4x is minus 5x, and plus 6 is kept as it is, over the denominator, which is x squared plus 2x. Now we care about the roots of the numerator and those of the denominator. The roots of the numerator are 1 and minus 6, again using the calculator as always we do. 1 and minus 6 for the numerator, and for the denominator they are 0 and minus 2. If you want to put this on the calculator, you put 1 for A, 2 for B, and 0 for C, because you don't have a constant, so 0 for C. Or you can factorize it and find the roots. You can use the method you like. So we are going to apply SOS for both, because as well as we have real roots, distinct real roots, two distinct real roots, that means that delta is positive. Okay? So when delta is positive, we use the idea of same, opposite, same according to A, the one or the coefficient of x squared. Now we make the table minus infinity plus infinity. We spread the roots mentioned here in the increasing order from minus 6, minus 2, 0, and 1. We put the first factor, the second factor, or the numerator, the denominator, and we apply same, opposite, same. First of all, you put zeros on the roots of the numerator. Minus 6 and 1 are the roots for the numerator. So same means minus. Opposite between the roots means plus. Same again minus. So according to the sign of A, it is minus. So same, opposite, same. Now the roots of this one are minus 2 and 0. And look that we put dashes because they are in the denominator. So x should not be 0 and x should not be minus 2, because they make the denominator 0 and that's undefined. So same as A is positive. So outside the roots, from minus infinity to minus 2, we have to put same as A. Opposite between the roots, you see here minus, and same outside the roots. Now multiplying the signs, we get minus, plus, dashes and zeros are down as you see here, minus and plus and minus. We need to get less than or equal to 0. So we care about the minus part. So we have to care about the minus part, which is here, here, and here. There are 3 regions where we have a minus sign. Thus, we take the solution 2 that's equal to minus infinity minus 6. We close it at 6 because we have or equal, then the numbers are included. Then union minus 2 and 0, but both are open because we have dashes, and x should not be minus 2 or x should not be 0. So that's why we open the interval even though we have or equal, but because these are rejected values, we don't have to let x be equal to minus 2 or 0. And final union, the last region, which is from 1, closed at 1 till plus infinity. And that's solution 2. So it's about a union of 3 intervals. Now how to get the final solution, which is using the number line. So we have to make a number line, as you see, from minus infinity to plus infinity. Again, we spread all the roots happened here along this line in the increasing order. So we start with minus 6, then minus 2, then 0, then 1, then 3. So we use the numbers mentioned here in the solutions. Now according to solution 1, I made it in blue. Solution 1 goes from minus 2 till 1, as you see, opened at both. That's why I make dashed segment. So from -2 to 1 and from 3 to plus infinity. The blue one is for solution 1. And the red one, it goes from -infinity to -6. Here you go. And the closed, that's why it's discrete. And union -2 to 0 again. So here is an intersection part. And union from 1 to plus infinity. So we search for the intersection part, which is here between -2 and 0, and here between 3 and infinity. Some may ask me, why didn't you take 1? There's an intersection at 1 here. I didn't take 1 because one of them is including 1, one of the solutions include 1, and the other one doesn't include 1. So I didn't take 1 among them because this solution includes 1, it's closed at 1, while this solution is opened at 1. So that's why I don't take, notice here it's opened at 1. So that's why I don't take 1. If this is closed at 1, for example, suppose if it is closed at 1, okay, and here is closed at 1, we just add this union singleton 1 because both solutions meet at 1 and it's included in both solutions. If this happens, then we add union singleton 1.